Welcome to Ask and Learn.
So, as per the question statement, what we have been given is that it says that we need to consider the problem 14.126, right? And says that if this system is operated as an adiabatic, right? As an
Here's a clean
adiabatic
and professionally formatted presentation of the calculations
system,
shown in the image.
right? And the air produced by the system, it has a relative
Application of the
humidity
work
of
energy theorem, wet.
80%.
From the work energy theorem, the force F is
Excuse
given
me.
by F
So
equals a
what is
frac
the
text
we are
KE,
required to
where KE
calculate
equals
the
kinetic energy, S equals
temperature
stopping distance.
of the
I'm given for
air
object A, FA
produced,
equals frac
right?
100,000,
So
0.10.
let's
For
start with
object
the
B,
solution
FB
for
equals
this
frac 225,
question.
1500 equals
Now the
0.15
solution for
text
this
makes
question
it.
is very
And force
easy, and
ratio
we are
frac
going to refer
FA,
to some of these
FB
values
equals
that we
frac
got in
0.10, 0.15
um,
equal frac
that we
2 null
obtained
result.
in the
A
previous
box frac
problem, that was
FA,
from
FB.
26, right?
Would you like
Now
a
in order to
PDF
solve this
version of
problem, we will
this
first
explanation?
need to use the psychrometric chart and the given temperature T1, right, that was equal to 40 degrees centigrade, and the relative humidity that was equal to 20%, right? So let me write it a little bit nicely. Uh, right, so we have the relative humidity that is equal to 20%, right? Now in order to determine the enthalpy and the absolute humidity, we got the values that were equal to 63.9 kilojoules per kilogram, and the value of the specific humidity it was equal to 0.0092. Right now, next what we are going to do is that we are going to use the energy balance equation, right? The energy balance equation, right? And by trial and error, we will determine the value of the enthalpy for the case 2 and the absolute humidity omega 2 for which the equation would be satisfied, right? So for this calculation, we will also need the value of the enthalpy of water, right? That is given at a temperature of that is equal to 20 degrees centigrade, right? So let's take a look at the energy balance equation. So on the left hand side we have the difference of the enthalpies, right? And on the right hand side we have the difference of the specific humidities times the enthalpy of water, right? So we need the value of this enthalpy and this specific humidity, right? And we have the value of the enthalpy. It's a one, the absolute humidity as well as the humidity. Sorry, the enthalpy of the water. From the previous question, we got its value that was equal to 83.915, right? Kilojoules per kilogram, right? Mm, so let us plug in the values that we have, right, in this equation, and let's take a look at the equation that we would have after plugging in the values, right? So we have 8 sub 2 negative 63.9 kilojoules per kilogram equal to parenthesis omega sub 2 remains the same because we are required to find out its value, and then we have negative the value of the omega sub 1 is equal to 0.0092, right? And that is multiplied with the um, enthalpy of water that is equal to 83.915 kilojoules per kilogram, right? To now what we're going to do is that we are going to approximate this equation for the enthalpy and specific humidity, right? And we get that the approximated value of the enthalpy is equal to 65.8 kilojoules per kilogram, and the approximated value of the specific humidity, it's equal to 0.01596. Right now that we have these values, we can use the psychrometric chart to determine the temperature, right, that is required, and depending upon these values, right? So the temperature, it would be equal to 25 degrees centigrade, right? And this concludes our solution for this question.